So a little bit of a review for you. We've learned that if we have one circuit or one switch or one light bulb, whatever you want to call it, one transistor, right? First generation computers had vacuum tubes. Second generation computers had transistors. Third generation computers had silicon wafers, chips, integrated electronics, all interchangeable words for this little guy. And, if we had just one light bulb, we could store two messages. And then we learned that if we had two light bulbs, we could store four messages. Well, my question for you is if we had 16 light bulbs, how many different messages could be stored and conveyed? Now remember, here was one with two light bulbs, right? So if we had two lights, we could store four messages. And if we had three lights, we could store eight messages, right? Three lights have those eight different combinations of on or off, and we can associate those with different, messages, different coding schemes. So my question for you is how many would we be able to store if we have 16 lights? 16 lights. How many different messages could we be able to store? So that's the question. Pause the video and figure it out. Okay, I guess you paused the video. Good for you. Remember, we want to use this equation right here. So 2 to the power of n. We could actually use Google to do that math for us. We could say 2 and then use that little caret character there to the power of 16. And that gives us 65,536 different possible combinations of on and off if we have 16 light bulbs lined up, right? There's 65,536 different possible combinations of on and off. So that means we could store 65,536 unique things in our coding scheme. This arrangement of on and off means X. This arrangement of on and off means Y, right? Just like if we had two of these, we could have, four possible combinations, both off, both on, this one off, this one on, this one off, right? We could have 4 with 2. With 16, we could have 65,536. So that's the answer to that one.